Hey guys, this is Karan here. I live in Saudi Arabia studying 9th grade in Yambu International School. Today, our topic is related to Newton's first law, which we already talked about. Now, Newton's first law says that object at rest tends to stay at rest unless unbalanced force is required. Now, why unbalanced? Why not balanced? Okay, let's talk about that. Balanced force. Okay, so when there's a balanced force, there's a net force of 0. So the object doesn't move, it stays in that position. Okay, now for example, tug of war. Okay, this is the rope, one person over here. Let's say 2 person. Okay. Okay, now he is pulling this side, okay, to win by 5 newtons. Okay, and he's pulling this side at 5 newtons. And this is the point. Okay, now what happens is that when they're pulling at the same amount of force, you guys can see 5 newtons and 5 newtons, this remains to stay at same place because this is a balanced force. Now suppose if this was a 6 newton, what happens is this side, this guy's right here would win the tug of war. And if this was greater, this guy would win the tug of war. And like that. So we can tell that unbalanced force is required to move an object. Okay? So now let's go on to the examples. Okay, now in this tutorial of kinematics, we'll be talking about calculating the displacement. Okay, displacement is a straight pathway from 2 points. Suppose that this was your house and this was your friend's house. Okay, now you go here and then you can go here, then you gotta go over here. Okay, now what can you do to make this distance short? Okay, well, you might be traveling in a car, but still you can make the distance short. How? Well, you just make a displacement. You just cut through the roads, cut through buildings. Okay, you just go straight pathway. That makes the displacement shorter. Now in some cases what happens is displacement is equal to the distance, but in rare cases, okay, sometimes. But the thing that is not possible is distance, which is right here. Distance is never less than displacement. Okay, it is never. Okay, now in some cases what happens is, let me just write in other color. This, I'm just gonna put this as big D and small d. Some cases they are equal, and most of the time what happens is this is less than distance. Displacement is less than distance. That is why we choose displacement to travel long distance in short period of time to save over time. Now in this example you won't be given that this in house and this has some values and calculate the displacement or distance. Well, you will be given 2 coordinate points, okay, and you need to find distance from that. Okay, so let's start our example with this one. It says that you walk from a location, okay, you walk from a location which is 12 blocks, just gonna block this B, okay, 12 blocks and 5 blocks, okay. 2, you go to a store, okay, you go to a store at -3 blocks. I'm just gonna put B blocks, and you do 1 block. So what's the displacement? Well, you're given coordinate points, right? Now what is -3 blocks? Why isn't it this positive? Well, in cases like this, if you go straight and then you go this way, that's a negative. Okay, keeping this in mind, how much did he travel? Okay, now displacement is represented as delta S. Okay, now what happens is final minus initial. Okay, so what do you mean by final? Starting point to ending point. So we do ending point minus starting point. So let's do it. -3 blocks. Okay, and then we have 1 block, and you subtract 12 blocks with 5 blocks. Okay, now what happens is you subtract this by this and this by this. Why? Because this is x, y, x, y. So you do x minus x, y minus y. But in this case, since the x over here is negative and over here is negative, we add them. Okay? So displacement is -3 plus -3 minus 12. Okay? So what is -3 minus 12? Well, it's 15. That is -15 blocks. Okay? Now we minus 1 minus 5, that we get it to be -4 blocks. Okay? You see the point over here. So this can be interpreted as walking 16 blocks to the west and then turning 4 blocks. Okay? So we can interpret this by going east, west, north, south, right? So we can interpret this as walking 15 units to west and then going down 4 units. Okay? And you get your displacement to be somewhere over here. Okay? Now let's move on to our next example. So our next example is converting a displacement vector from the previous example to polar form. Okay? Now in this example we will be changing our units, such as our answer was -15 and -4, but in this case we will be using -16 and 3, -3. Okay? And this is the displacement that we got. Now what happens is we need to find the polar form. How do you find the polar form? Watch and learn. Okay? So you just make a silly triangle, which is right triangle. Okay? So we can use trigonometry in this physics. Okay? Now the longest distance is over here, so you put 16 over here. Okay? And it's not always the longest distance, just because if you were to make a line from here until here, this would represent x and this would be y, right? And so this is x and this is y. That is the reason why we put x and y. But to make things easier for you guys, big unit goes over here, and we don't write negative because, like I told you before, it's not really negative. A distance can never be negative, but since we are moving down and to the west direction and to the south direction, we can represent the distance as negative, okay? But it's never negative. So we put 16 here, let's put 3 here. Now you find the Pythagorean theorem. Okay? Now if you were to find the Pythagorean theorem, first you need to find the angle, which is represented as, you might be not able to see, it's this symbol over here, which means theta. Okay? Now what you do is c squared is equal to a squared plus b squared, which everybody knows is a Pythagorean theorem. Okay? C squared is what we don't know. 3 squared plus 16 squared. Okay? We can also write this as S is equal to, and again we are not subtracting something, so we can't write delta S. It's just S. Okay? That means displacement is equal to square root of 265. That is blocks, right? And that is squared. So we can tell that this when you do this, you get your answer to be 16.3. Okay, now you do tangent, you use tangent, okay, because, okay, let me tell you this, you use tangent because you have opposite angle over here, opposite side over here, and adjacent side over here, okay, and this is hypotenuse, okay, opposite O, adjacent A. So tangent of theta is equal to opposite over adjacent. So you do 3 divided by 16 and then tangent sign in your calculator. That would give you a number. And that number would be, let me just write tangent of theta, would give you your answer to be 0.1875. That is in degrees. Okay, now the only tricky part here is now we must find the angle from our tangent of the triangle. Okay, on your calculator you will see tangent -1, which is called inverse of tangent. It looks like this. Okay, let me just erase this part up here. Okay, tangent, this is called inverse of tangent, and when you plug inverse of tangent to 0.1875, you would be getting your answer, okay, you would be getting your answer to be 190.6, because here we get this answer because we need, since this is in third quadrant, we must do it easily by adding 180. This gives us result of 190.6. Okay, so now that we have converted component form into polar form, okay, let's go ahead and find the speed of it. How would you calculate the speed? Well, speed equals displacement over time or distance over time. Okay, well, we don't know the distance over here yet. We do know is displacement, so we can write our formula as velocity is equal to displacement over time. Okay, now for the displacement we got 16.3. That is 16.3 as a displacement and 190.6. So let's cut off the parts we don't really need. And if you want to learn more in trigonometry, I have given you ratios, which is useful for time being, so you might want to look them. When this video finishes, I'll post a link up so you can click on the screen. Okay, so how do you write this thing? Well, you write as 16.3 at the angle of 190. Okay, 190.6. Okay, and how much time did it took? Well, here no time is given, so I'm going to give you a time. That is 38 minutes. Well, divided by 38 minutes. Okay, now the thing is, you don't actually divide this. So how do you write this? Well, you write it as this, 16.3 divided by 38 is the angle of 190.6. Okay, now if you were to divide that, you'd be getting 0.43 blocks per minute at the angle. Okay, hold on. 0.43 blocks per minute, okay, at the angle of 190.6 degrees. Okay, and that is the velocity. Okay, so we are traveling 0.43 blocks per minute. Okay, so I would like you to get introduced with this equations up here. It will help you in later problems. That is, the first one, speed is equal to velocity times time, okay, plus initial displacement. Okay. Now the second one is displacement is equal to velocity times time. Okay. Now the third one that I would like you to understand is velocity is equal to initial velocity plus a times t. Okay, then you have displacement again, and as you guys can see, we already have displacement formula, but it doesn't always work out that way, that we are given velocity and time in each and every problem to find the displacement. No, it doesn't work out that way. Initial velocity times time plus half at squared, I think. Yep. So now there's more, so I'm going to erase the first one up here and continue with our equations. Velocity squared is equal to initial velocity squared plus 2 times a times displacement, I think. Yes. Now, knowing this formula, after so many formulas, right? So, knowing this formulas, let's go ahead and solve some examples. Now, I'm going to give you a second just to write down the formulas. Okay? Okay, so I'm going to erase with this one first, then this one, and then if I erased it too early, you can pause the video, go back, and write the formulas down. Well, here the problem says a car travels at constant velocity of 23 meters per second. How long will it take to cover 5 kilometers? Well, we always write what's given. Well, the distance is given 5 kilometers. The velocity is given to us as 23 meters per second. 23 meters per second. Because it's constant, its initial velocity is going to be the same as well. Okay, now time, we really don't know. Okay, now using this, an acceleration is 0 because when the velocity is constant, you're not increasing or decreasing, so the acceleration in this problem is 0 meter per second as well. Meter per second squared. Okay, so by looking at some of the equation which I just told you over here, okay, we are going to use the formula which I'm just going to show you. Is displacement is equal to initial velocity times time plus half at squared. Okay, now for displacement we can't put 5 kilometers, okay, so we put 5,000 meters is equal to initial velocity, which is 23, times time, which is we don't know, plus half, acceleration is 0, times t squared. And we take all this as 0 because we're multiplying this by 0, and whatever we get, we multiplying this by 0. Well, if you multiply any number by 0, you'll be getting 0 as well. So let's consider this to be 0 plus, okay, 23t is equal to 5,000. When you divide 23 on both sides, you should be getting the time to be you'll be getting the answer in seconds, but then you convert it to minutes. So 217.4 seconds. Now here I'm going to show you how to convert it into minutes. Okay. Now, since there is a lot of stuff on board, let's go ahead and erase all the things which we really don't need. Okay. Now this is in seconds, right? So we know that we start off with this number, 217.4 seconds. And we know that each 60 seconds there is 1 minute. And that is what we want. So seconds cancels out. So when you do this, you should be getting your answer to be 3.62 minutes. Okay? So I hope this tutorial helped you using equations a lot. Now here I just used one problem to show you, and you can use many problems such as just replacing the units, okay, and using different formulas. You can make up your own quotient to get real expert at solving the equations like this. So you don't really need to write down what's given every single time. When you are mastered with the problems over here, you understand physics. Okay, thank you for watching.